Welcome. We're about to pull back the curtain on a GCSE physics exam question. We're not just going to find the answer. Oh no. We're going to dissect the official mark scheme to see exactly how you can earn every single mark, straight from the people who write the exams.
So here's our game plan. We're going to break down question 05 piece by piece. We'll look at the question and then jump straight into the mark scheme to get inside the examiner's head. All right, let's dive in. First up, we're diving into a really core idea for any science experiment: errors and uncertainty. This part of the question is basically asking, hey, why aren't all your results exactly the same? It's a test of what's causing that little bit of variation. Okay, so the question seems pretty straightforward, right? But hold on. The key is in the wording. It's asking for the specific type of error that creates a range of values. This is all about using the right terminology.
And boom, here's our first massive clue from the mark scheme. The only answer that gets you the mark is random. Now, look at that extra info column. It literally says human error is insufficient. This is a perfect example of where you've got to use the precise scientific term. It's non-negotiable.
Okay, so let's build on that. The next part of the question connects that theory of random error to what a student might have actually, done wrong in the lab. So they want to know, what did the student actually do to cause that random error we just talked about? The examiner is looking for a real-world, practical example from the experiment itself. And check this out. This is such a perfect example of why you've got to be specific. The mark scheme accepts things like misjudging the center of the ray or not putting the mirror back in the same spot. But look at what they reject: vague stuff like measuring incorrectly. That's not enough. You have to explain how it was measured incorrectly to get that mark. All right, time to crunch some numbers. We've got a calculation question here, and it's worth 2 marks, so showing your work is absolutely key. Now, look closely at how it's phrased. There are 2 clear commands here. Number 1, estimate the uncertainty. Number 2, show how you determine your estimate. 2 instructions, 2 marks. Easy peasy. And this is so important to see. The marks are split into 2 chunks. You get the first one just for processing the data correctly, like finding the range or the mean. The second mark is for the final answer. It's like a safety net. Even if you mess up the very last step, you can still walk away with half the points. And here's the mark scheme to prove it. For that first mark, you could show that the range is 10 or that the mean is 51. Either one works. For the second mark, you just state the uncertainty. And hey, look at that helpful little note. If you just write down the correct final answer, 5 degrees, you get both marks automatically. So there it is. The final uncertainty is 5 degrees. Just a quick reminder of how that works, right? You take the full range of the results, which in this case was 10 degrees, and you just have it. That gives you that plus or minus value around the average. Okay, let's shift gears a bit now. This next part tests a totally different skill. It's not about math. It's about being a detective, looking at the data and building a solid argument. And here's another one of those questions that's secretly asking for 2 things. First, you've got to pick a side. Do you agree with the student or not? But then, and this is the clincher, you must use specific examples from the results table to prove your point. Now, this is fantastic. I absolutely love this. The mark scheme explicitly says you can argue either for or against the conclusion. There's no single correct opinion here. The points are all about how well you justify your position. So that first mark, you get that just for stating your case clearly. But the second mark, that's where the real points are. It's all about quoting the data. You could say, hey, at 20, 30, and 40 degrees, some of the results match up perfectly. Or you could argue that at 50 degrees, the differences are so big that they cast doubt on the whole thing. Either way is fine as long as you use the evidence. Let's just zoom in on this little gem in the mark scheme. Allow 50 degrees includes anomalous results. This is huge. It means the examiner is actually rewarding you for spotting weird data points, for identifying outliers. That's a top-level science skill, and they give you credit for it. All right, we're on the home stretch now. Let's look at the very last part of question 05. This is all about putting on your scientist hat and thinking, okay, what would I do next? So the question is, what's next? If you were the student, how would you make your conclusion stronger? How could you make it more, bulletproof? Now, there isn't one single right answer here, but what they're testing is your understanding of how to make experiments better. An examiner would be looking for things like
taking more readings at new angles, maybe 25 or 35 degrees, or even just repeating the measurements you've already taken to get a more reliable average. Anything that logically makes the evidence stronger would get you the mark.
So, after that deep dive into just one question, what's the big picture? What have we really learned from getting a peek at the examiner's playbook?
So, what's the secret sauce for scoring marks? Well, it really boils down to this. Use the precise scientific language. Give specific practical examples, not vague ideas. Show all your work in calculations. And always back up your arguments with data from the question. Mastering this isn't just about learning physics, it's about learning the rules of the game. Look, at the end of the day, understanding the mark scheme is your secret weapon. It changes your revision from just learning stuff to learning the strategy of the exam. So think about what we've covered and ask yourself, what's the first thing you're going to apply to your revision? Good luck.